Hello, my name is Sheela, working as an assistant professor in Chalapati Institute of Engineering and Technology. Today I want to discuss about the topic socket application interface. Before that, what is a socket? A socket is an interface between application and network. So in the socket application, we have the creation and setup, how to establish a connection, sending and receiving the data, tear down a connection. These are all comes under the interaction between the client and server. Here we are taking the example of the transmission control protocol. By using the transmission control protocol from one host to another host, how the socket creation and what is the setup will be done, and how to establish a connection, and how to send and receive the data, and how to tear down a connection. These are all we will discuss in the socket application interface. Before that, what is a socket function? Here in this, see the diagram representation here. Here we have the two hosts. One is the client and another is the server. There we are taking the example of the TCP client and the TCP server. And here at the server side, we have the well-known ports are there. Here the well-known ports is nothing but a socket creation, bind, listen and accept. Here the socket. At the TCP server side, first of all we have to do the socket creation. And after that we have to do the bind function. And after that listen function will be there. So listen mode. And after that we will accept the connection. At the server side, it is in the passive open state. It is in the passive open. Whereas in the client side, it is in the active open state. Active open state. And okay, coming to the server side. So whenever the socket creation, bind, listen and accept will be done, here the acceptance is nothing but it's one type of function which will wait for the connection. It won't initiate the connection. At the server, it will wait for the connection, it won't initiate the connection. Coming to the client side, here the socket creation will be done, and after that connection will be established by using the TCP three-way handshake. In the previous video, I explained about the TCP three-way handshake. Okay, and after that connect, by using the connect function, the connection will be established successfully. And after that, the write function at the client side will be there. From that the data will be sent to the server, and from the server side, from the read function, the data will be read by the server by using the network. This is the general process. And after this, see here, after the read function at the server side, the process request will be done, and after that the server will again, it will write some data by using the write function, and the server will again send and reply to the client side. And here the client, TCP client will read the data by using the read function, and even though the transmission of the data is successfully done, then after the client will send an close function. That close function is read by the server side and the function will be closed. This is the entire socket function diagram representation for the TCP client and the TCP server. So here we have used different types of functions like socket function, bind function, listen, accept, write, read, close. Now we will discuss about the individual functions and what is the functionalities of that individual functions we will explain now. Here the socket creation and setup. While we are using this socket creation, mandatory we have to use the header file like system/socket.h. We have to include this header file like sys/socket.h, and to create a socket we have to use the function like int socket, within the bracket int domain, type and the protocol. Here the domain is nothing but a protocol family, and the type type is nothing but a style of communication, whether we have to choose the TCP protocol or we have to use the user datagram protocol. Which style of communication we have to choose, there we have to mention. And the int protocol. Initially the protocol which it contains the initial value is 0 value we are taking, and if the socket creation is successful, it returns to the file descriptor. If it is failure, it returns the -1 for the socket creation. Here the socket creation will be done both at the client side and at the server side. So whenever the client and server want to communicate, based upon the socket pair only, the communication will be done between the two hosts. Coming to the bind function. Here the bind function, to bind a socket, for the bind function, it must and should have the IP address and the port number. Based upon the IP address and the port number, the connection will be bind. Here for this, we have to use the function like int bind socket file descriptor struct socket addr my addr int addr len. Here the my addr is nothing but here the bind function will be done at the server side. So what is the server's IP address and the server port number? In the my addr, it will represents the server address. And the socket file descriptor is nothing but suppose in the Unix, for the files we will use the file descriptor, whereas for the client and server interaction, by using the socket where the data it is transmitting. So for that we need the socket file descriptor. In generally, in the bind function, we will put the socket into the passive state. So here it will wait for the connection, not for to initiate a connection. And after that, coming to the listen. Here into the listen state, we have the two arguments like socket file descriptor and the backlog. Okay. Here the backlog and the socket file descriptor. And for the accept connection, here we have the int accept socket file descriptor, socket addr, CLI addr, int star addr len. Here this is at the server side. The acceptance function will be at the server side. Whenever any new connection is come to the server side, the acceptance will be done. So here whenever the acceptance is done, so here at the server side, it has to know the client IP address and the client port number. So that's why CLI addr is nothing but a client address. Here it has to mention for the acceptance of the connection at the server side, there we have to specify the client address and the client port number, and in generally address length, how much of data it want to send or it want to transmit how much of data. Before that only it has to mention the address length also. Then only the acceptance will be done. And here if it is successful, it will returns the file descriptor. If -1 means the failure is occurred. This is the socket creation and the setup, and one by one we will see in detail. For the socket creation, here I told that int socket. In the int socket means int is nothing but a return type. So socket, it is a file name. Here the socket int domain and the type and the protocol. Successful means I told that return file descriptor -1 if any error is occurred. The domain is nothing but an protocol family. Okay, and here protocol family is nothing but an it may take the protocol family is nothing but it will take the IPv4 Internet Protocol version v4 it can take, or IPv6. Generally we will take the IPv4 version, and other possibilities also we can take like protocol Unix or Unix sockets IPv6 we can take, but in general we are taking the example of the IPv4. And the type is nothing but a style of communication. So in the style of communication we can take the TCP or UDP, where we are taking the TCP is nothing but sock underscore strem, and UDP means sock underscore DG/RAM. So in that way we have to choose the style of communication. And the protocol is nothing but within the family, typically it will take the 0. And here the protocols, for list of protocols will be there. Based upon that, it will choose. Typically, by default, it will take the 0 value. From the next slide, the bind function. So in the bind function, we have the 3 arguments. Int, the return type is int bind, int socket file descriptor, struct sock addr, my addr, int address length. Okay. In this bind function, the socket contains a local IP address and the local port number. If it is successful, it will return 0, -1 if any error is occurred. Sock FD is nothing but a socket file descriptor. And here, my addr, it includes the IP address and the port number. IP address is set by the kernel if value passed in addr underscore any, else set by caller, and the port number is set by kernel if value passed is 0, else set up caller. And the address length is length of the address structure, generally which it contains the size of struct sock addr underscore in. After this connection, here in generally the socket underscore state is equal to TCP underscore close. It is in the up to the bind connection, the TCP connection will be in the closed state. Here we are taking the binding the connection, socket creation and binding connection is done at the TCP by using the TCP protocol, and here the state is in the TCP closing state. Coming to the listen state. In the listen state, we have the 2 arguments like socket file descriptor and the backlog. Okay. Here, generally in this, the socket is put into the passive state. It is nothing but a passive state is nothing but an wait for a connection rather than initiate a connection. If it is written 0, when the success, -1 or error will occur when it is in failure. Socket FT is nothing but a socket file descriptor. Here the backlog means bound on length of unexpected connection queue. Here connection backlog. And here the socket underscore state is in the TCP listen state, whereas in the bind function it is in the closed state. Here the whenever it is coming to the bind to listen function, it will come to the TCP will come to the listen state, TCP underscore listen state. Coming to the accept. Int accept, within the bracket we have the 3 arguments: socket file descriptor, struct sock and addr star CLI addr, and after that int star addr LAN. Here there is star is nothing but a pointer representation which stores the address of that. Okay, it accepts by using the accept connection, it accepts a new connection which is coming from the another host. If it is successful, it returns the file descriptor -1 whenever the error is occurred or failure. The sock FD is nothing but a socket file descriptor. CLI addr is an IP address and the port number of the client, means which is written for call. addr LAN is nothing but length of the address structure is equal to pointer to int set of size of struct sock addr underscore in. Here the addr LAN is a value result argument. It is a value result argument. The caller passes the size of the address structure. The kernel returns the size of the client address, the number of bytes returned. Here from the client to server interaction, here the client has to mention the address length also. So based upon the address length, the server side, it has to accept the length. So it has to accept the length, how much of data it has to transfer. So here the kernel returns the size of the client address. Here the kernel will act as a mediator between the client and the server. For the interaction, it will send how much of address the client want to send. In that way, the server will accept the connection. if a new socket was cloned from the listening socket, after the listening function, if a new socket was cloned from the listening socket, there are no incoming connections to accept. Okay, if there are no incoming connections to accept, it is of two ways: non-blocking, blocking. Non-blocking means accept operation failed and throw away the new socket. Blocking means accept operation was added to the wait queue. It is a default. Okay, now we will see the TCP connection setup. Here in this TCP connection setup, it is a three-way handshake. See this diagram, there is a client and the server will be there. At the server side, we have the socket, bind, listen, accept are there, right? And after that, at the client side, the after the socket creation, for the by using the connect function, the connection will be established synchronization with the sequence number J, and the server side will send, while receiving that synchronizations J, the server will send an acknowledgement by adding the +1 to the client synchronization number, and also it will send an synchronization K, and after the connect completes at the client side, again it sends an ACK of the server's synchronization number by adding 1. This is the entire connection mode to the complete queue. So here the connection is established in this way. So here the connection moved to the complete queue. Why? Because in general the server can communicate with the multiple clients at a time, right? Multiple clients at a time. So whatever the new connections are there, all those connections will be stored in the form of a queue at the server side. Here this connection will be formed in the queue, and these will be these are to be and the kernel will take care about that. So whatever the new connections are there, those connections will be stored in the form of a queue at the server side. Whenever a previous connection is completed and the close, and the new connection will be taken from the queue at the server side, and the communication will be done. Okay, thank you. And on next video we will discuss about the programming for the TCP connection setup. Okay.